Hello, this is Mr. Mola for Lesson 1-8, Introduction to Functions. So a couple different things we're going to do today. So identify the parts of the coordinate plane, graph the ordered pairs on the coordinate plane, and then use our input values to substitute to make a graph. Alright, so we have a couple vocab words here that we'll go over in class. The first thing we need to know is our coordinates on the plane. So this is our coordinate plane, so kind of just like a number line, except it's basically just two number lines. So it's a horizontal and a vertical number line. Same thing, left is negative, right is positive, up is positive, down is negative. Some of the questions on homework will literally just ask you, hey, here's a dot on the graph, what coordinate or what quadrant is it in? So this square over here is going to be quadrant 1, this square over here is going to be quadrant 2, this square over here is going to be quadrant 3, and this one's going to be quadrant 4. Remember, when we're looking at graphs, so if I'm trying to graph -4, 4, this first number is always going to tell us how much left or right I'm going to go. So since it's a -4, I'm going to go 4 to the left, and then it says +4, so that means I'm going to go 4 up. So our dot should be right there. 0, -5. Means I'm going to go left or right 0, so I'm going to stay there at the origin, and then go down 5, so I should have a dot right there. And then dot V, so it's -2, -3, so I'm going to go left 2, down 3, so I should have a dot right there. Kind of the same thing here. 2, 3 means right 2, down 3. 0, 2 means left or right 0, up 2, and then -2, 6 means left 2, up 6. And then here's some examples for quadrants. So point E right here is in quadrant 2. Point F is right on the line, so we would say that's on the F axis. Point G is in quadrant 1, and then H is in quadrant 3. Same thing here. T is on the Y axis, U is in quadrant 1, V is in quadrant 3, W is in quadrant 2. So when they're talking about graphing it, this is what they're talking about, our input and our output. So usually they're going to tell us the X. So whatever I put in, I'm going to put in a number for X, and whatever I get out is the output. You've done this before in younger grades, except you usually call them in and out boxes or in and out machines. Usually figuring out what the rule is, and usually it's just like a one-time thing where it's, oh, you're adding 3 to all these numbers. This time now in 8th grade, it's usually going to be multiplying by a number and then adding a number as well. Another word for this is domain and range. So input is the domain, output is the range. So if I'm looking at a box like this, here's my problem, 2x plus 1. And then I do a few math problems here to get my points. So if x is -2, so I have -2 times a -2 plus 1, my answer is going to be 3. So my input is going to be -2 because that's what I put in for x, and my output is going to be -3. So then there is a dot at -2, -3 right there. Okay, same thing here. I put in -1. 2 times -1 is -2, plus 1 is going to give me -1. So that means I put in a -1 and I got out a -1. So -1, -1, there's a dot there. When you're doing this, I would pick small numbers like this so that you're not doing a whole big multiplication, and then this way you're not graphing. If you put in the number -100, well, that means you're going to have to make a graph that goes all the way down to -100. So it's a lot easier sometimes to put in these low numbers, so I pretty much use these 5 numbers as our standard. Let's do some positive numbers so we kind of get the gist of it. So like if I put in 1 here, so remember my rule is 2 times and then plus 1. So if I put in 1, 2 times 1 is 2, plus 1 is 3. So I put in 1 and I got out 3. So I put a dot at 1, 3. The wonderful thing about this is it pretty much corrects itself. Since you guys are taking linear algebra, everything that you graph here should be a straight line. If it's not a straight line, something went wrong. Sometimes you're off by, one number. You can tell if it kind of curves that something went wrong with your graphing. Every time we graph something that looks like this, it's going to be a straight line. Sometimes we'll graph something that says x squared. That's not going to be a straight line. Or if we're graphing absolute value, that's not going to be a straight line. But as long as there's no exponents or absolute value, everything should be a straight line. So here's one that's not going to be a straight line. Since it says x squared, nothing changes. It's going to be the same. Okay, so let's say I put in 2 here. So I have x squared minus 3. Okay, so if I put in a 2, 2 times 2 is 4, or 2 to the second power is 4. 4 minus 3 is 1. So I put in a 2, got out a 1. I'm going to put a dot at 2, 1. And you'll see if I have an x squared in my problem, it always makes this U shape, and we call this in math a parabola. Okay, so the straight line is going to be just an x. A parabola, or that U shape, is going to be x squared. And then if I ever am graphing something that says absolute value, it's going to have a V shape. So again, right away I know if I did something wrong, if I don't get that V shape for an absolute value, or if I don't get a U shape for a parabola, or for an exponent, then I know something went wrong. So we'll do a couple of these with the absolute value. So my rule here is x minus 2. So let's say I pick 2. So 2 minus 2 is 0. Absolute value of 0 is 0. So I put in a 2. I got out a 0. There's my point right there. Okay, if I put in a 4, 4 minus 2 is 2. So I put in a 4, got out a 2. There's my 4, 2 point right there. And remember, absolute value is always going to be positive. So even if I do put in a 1, 1 minus 2 is negative 1. But the absolute value of negative 1 is 1. So then I would graph the points 1 and 1. And there that is right there. Remember, absolute value always has that V shape.